All right, so you're going to graph y equals sine x. Label your x-axes with angles. Pi over 2, pi, 3 pi over 2, 2 pi. On your y-axis, you need 1 and negative 1. And actually, I want to graph some more of this on the left. So graph your negative angles as well. Okay, so sine starts at 0, 0, up, midline, down, midline. So that's one period of sine. And then follow the pattern backwards. That's negative 1. Okay, so when you have sine there, I want you to start thinking about how you would change a sine graph to an inverse sine graph. Do you remember graphing inverses in Algebra 2? Do you remember finding inverses in Algebra 2? If I gave you an equation like y equals 2x plus 3, and I asked you to find the inverse, what would be the first step? Switching the x and y is absolutely right. So what we need to be able to do with this graph is we need to switch the x and y. If I just turn it, though, like this, I have negatives down here, positives up here, but there's a problem because on my new x-axis that used to be my y-axis, I have positive 1 here and I have negative 1 here. So we need to think of a way where we can switch our x and y-axis, but the positives and negatives make sense. You see that here? Like I switched it so that now my new y-axis is my old x-axis. And I have negatives on the bottom and positives on the top. That's all good. But my new x-axis, there's a problem there because I have negative 1 here and positive 1 here. All right, so say that again, Emily. What are you going to do? Like turn it upside down? Yeah. Okay, so if I turn it upside down, and this is the whole purpose for the paper, so she was right. You want to, after you turn it upside down, say it's like in the wrong place, you need to find your negative 1 and put your negative 1 on the left. Whoa. All right, so now negative 1's on the left, positive 1's on the right. I have my positive angles on the top, and I have my negative angles on the bottom. So this is all good. But what's the problem with my graph now? If you look at that graph, that crazy S shape going back and forth, is that a function? I heard a couple no's. Why is it not a function? What do you think? Give it a guess. What's that called? Starts with a V. What kind of line is this, guys? Is this horizontal or vertical? Vertical. Okay. This is the vertical line test. The vertical line test checks to see if every input has just one output. And if it crosses more than one point, then you have inputs with more than one output, right? So what we need to do is we need just a piece of this graph. Okay. If I took that piece right there, does it pass the vertical line test? No. No, it doesn't. If I just take this piece here, it still doesn't. I'm going to take that piece there and this piece right here. Okay? So for your inverse sine graph, you have to just take this one piece that comes from your sine graph, and that's all you get, because other than that, you're going to start repeating x values, and that's no good. Okay? So your inverse sine graph goes from negative 1 to 1 on the x-axis, and from negative pi over 2 to pi over 2 on the y-axis. So on your notes, we're going to draw that. Okay. This paper here. You guys don't have that one? Okay. Okay. You have a point here, here, and here. Now, you need to make sure you get the inflection correct here. This is called concave down. It looks like a rainbow. This is called concave up. It looks like an upside down rainbow. Okay? Over here, this is just the regular sine graph, the one that we graphed in the first place.
What kind of question is that?
Didn't you?
Okay. Restricted range, negative pi over 2 to pi over 2. It looks like it's talking about this graph, but if you look carefully, this is really talking about this graph. And the restricted domain is also talking about this graph. Now I want you to notice that there are two ways to say inverse sine. You can write that sine with a -1, which looks like it's a -1 power, but it's not. That's red inverse sine. And this one means exactly the same thing as inverse sine, but you read it as arc sine. Okay? So in our packet, in our notes, we're almost exclusively using this notation, but on your homework, you'll see this notation too. All right, so what that means is when I do inverse sine, if I did a problem like the problem on the warm-up, if I asked you for inverse sine of 1/2, I would only want answers between negative pi over 2 and pi over 2. So let's think about what that looks like on the unit circle. Negative pi over 2 is down here. Pi over 2 is up here. So negative angles are when you go backwards. Positive angles are when you go this way. So if I had an angle in the fourth quadrant, instead of calling that like 11 pi over 6, I would call it negative pi over 6. Remember, you'd just be heading clockwise instead of counterclockwise. So this is negative pi over 6, negative pi over 4, negative pi over 3. And then the first quadrant is the same first quadrant that you know and love. Pi over 6, pi over 4, and pi over 3. So if you're doing an inverse sine problem, these are your only possible answers. You're never going to have anything in the second or third quadrant. And if you have a fourth quadrant answer, you need to write it as a negative angle. So you'll never have a second or third quadrant answer for an inverse sine problem. And if you have a fourth quadrant answer, you have to write it as the negative angle. So we have 3 examples right here. I'm going to give you a minute to try to answer them. The only possible answers are these angles right here. Okay? So take a minute to try to answer them, and then we'll go over those. 1, you're asking yourself, what angle has a sine of 1/2? Eva, what did you get for that one?
I got pi over 6.
Anybody else get pi over 6 or 30 degrees? Okay, very good. So the angle that has a sine of 1/2 is pi over 6 or 30 degrees. If the instructions don't say whether to use degrees or radians, you're allowed to do either, but know them both because you might get a quiz or test that says answer in radians or answer in degrees, okay? So make sure you know both. All right, the next one, Shakira, what'd you get for B?
Negative pi over 4.
Anybody else get negative pi over 4? Okay, negative pi over 4 is good, and in degrees, what would that be? Negative 45 degrees. Now, if you wrote 7 pi over 4, you were looking at the right quadrant, but you forgot that the answer has to land between negative pi over 2 and pi over 2. So 7 pi over 4 is too big. You got to do that coterminal angle that is back here when you go the other direction, negative pi over 4. Same thing if you wrote 315 degrees. It's also not right. So if you have 315 degrees, you need to look at that same part of the circle and name it negative 45 degrees when you go backwards. Who has a question on that? All right, raise your hand if you have the last one. It's tricky because it's saying what angle has a sine of 0. Raise your hand if you got that one. I'm still looking. Tara, what'd you get?
0.
Anybody else get 0? Okay, so 0 is right here, and the sine of 0 is 0. That's right. I did hear somebody say 2 pi. 2 pi is talking about the same part of the circle, but remember that your answer has to be between negative pi over 2 and pi over 2. Nope, not in this class. This is 602, not 262.
No, it says 602. Like it's for SS.
Oh, you know what? Actually, I think he's in the other class. Okay, thank you. Gotcha. All right, any questions on those before we do cosine? So we're going to do the same thing for cosine with your paper. We're going to graph cosine in a different square, okay? And then we're going to flip it and see what the inverse looks like. So we're going to graph cosine. All right, so when I turn it over, I want to switch my x and y. So now my y-axis is my new x-axis. -1 should be on the left, and 1 should be on the right. Now, if I take the same section of the graph that I took before, which was right here, does it pass the vertical line test? No, so I have to choose a different section. So I want my first quadrant, that's right here, and I'm going to choose this part right here. Awesome. So, this time, your x's still go from -1 to 1, but your y's go from 0 to pi. Okay, so when you are copying that over here onto your notes, you need to keep that in mind. Okay, so my inverse graph is still -1 to 1 on the x-axis, but on the y-axis, if that's pi over 2, and that's pi, it's going to stay above the x-axis. Notice your inflection. This is concave up, and this is concave down. Over here is your regular cosine graph.
Do quick math.
On the patty paper. So notice here it tells you that the range for inverse cosine is negative 0 to pi, and the domain is still -1 to 1. Inverse cosine can be written this way, or it can be written as arc cosine. They mean exactly the same thing. One thing we skipped over up here is cosecant. Remember, you can have an inverse cosecant also. We didn't graph it. That's okay. Inverse cosecant is going to have the same restricted range as sine. Okay? Inverse sine. So inverse sine and inverse cosecant, sorry, that's up here. Inverse sine and inverse cosecant are both -pi over 2 to pi over 2. And cosine is going to be 0 to pi. Inverse cosine. So when you're ready, you're going to turn the page and we're going to answer some questions. And those questions, the answers will be between 0 and pi. We're not talking about negative angles when we do inverse cosine. Greg? Turn the page.
Sorry, I had to finish writing something.
Anybody still looking at this before I turn to the next page? Okay. So just like we made a picture up here for inverse sine, we're going to make a picture for inverse cosine. So your answers are between 0 and pi. They're all positive angles. So pi over 6, pi over 4, pi over 3, 2 pi over 3, 3 pi over 4, and 5 pi over 6. So those are the only possible answers. For cosine, remember you're looking for angles that have an x value of this ratio. So you're asking yourself, what angle has this cosine? So take a minute to answer those. Who has the first one? Courtney. Okay, Courtney gets pi over 3. Anybody else get pi over 3? Yeah? Okay. Or what degrees? Okay, raise your hand if you have cosine 0. Oh, inverse cosine 0. Kieran. Anybody else get pi over 2? Good. Awesome. Okay, raise your hand if you got negative root 2 over 2. Only one person? 2, 3 people? 4 people? Colleen, what'd you get? Both answers, very nice. 3 pi over 4 or 135 degrees. You don't have to write both answers, but I wanted you to be able to see if your answers were right or not. Anybody have a question on those 3? Go ahead. On this one? Okay, for this one, you're trying to figure out what angle has a cosine of 0. And remember that cosine is the x value. So the coordinate up here is 0, 1. And the x value is 0. So, okay. All right, guys, for tangent, we're going to go back to your see-through paper. And you're going to graph tangent. Remember, tangent has asymptotes at negative pi over 2 and pi over 2. And it's an increasing function. Okay, so take a minute to graph that and then turn it to find the inverse. You can find the inverse. All right, so my negative one's on the left, my one's on the right. Notice inverse tangent is also an increasing function, but now the asymptotes are horizontal asymptotes. So you have horizontal asymptotes at negative pi over 2 and at pi over 2. And then you have these points at negative 1, negative pi over 4, and positive 1, positive pi over 4. So we need to copy that over here. All right, so remember that these notes about domain and range, these are all for the inverse graph. So negative pi over 2 to pi over 2, is that the same as sine or as cosine? These answers can be negative pi over 2 to pi over 2. Think back to 5 minutes ago. Did we have answers from negative pi over 2 to pi over 2 for inverse sine or for inverse cosine? All right, we're going to have to look back then. It wasn't inverse cosine, that was 0 to pi. It was back here as inverse sine. So when you do your inverse tangent problems down here, you also want answers from negative pi over 2 to pi over 2. Okay, tangents are trickier to figure out because it's not just the x, it's not just the y, it's the y over the x. You have to actually divide it and do some work. So there's a little bit of guess and check involved until you have these tangents memorized. So write down the coordinates for the points and then try the 3 problems. Annabelle, did you get the first one, inverse tangent 1? Okay, so pi over 4, if you do root 2 over 2 divided by root 2 over 2, that gives you 1. That's good. Christina, did you get B? Okay, so 30 degrees is right here at pi over 6, right? So to check it, we would do 1/2 over root 3 over 2. And those canceled. And I have 1 over root 3, which you want to rationalize. So you get root 3 over 3. So she picked the right one. The answer is pi over 6 or 30 degrees. Okay, raise your hand if you have C. Who has C? I see 1 hand. 2 hands, 3 hands. Emily, what'd you write?
Negative pi over 3 or negative 60 degrees.
Okay, did you divide it to make sure?
Yes.
Or did you just know?
Well, I kind of just knew that I divided.
Okay, so eventually you get used to this. There's not that many tangents around the circle, right? There's root 3 over 3, and there's root 3, and then there's 0 and undefined, and that's it, okay? Those are the only possibilities. So if you divide this, you do get negative root 3, so she picked the right one, and it's negative pi over 3 or negative 60 degrees. All right, so your last graph, you're graphing cotangent.
Yo, Greg, what's the last graph?
Okay, cotangent has asymptotes at 0 and at pi. Cotangent is decreasing. Okay? So here's your cotangent graph here. When you flip it and you turn it, you're going to discover that your answers are between 0 and pi. So you have an asymptote right here at 0, and you have an asymptote up here at pi. You need a -1 and a 1. Okay, so that's your inverse. Then graph your regular cotangent as well. So for inverse cotangent, you notice that the answers are between 0 and pi. So we're going to make a list Functions that have answers between 0 and pi are inverse cotangent. And what else? 0 and pi, that was inverse cosine. And then the reciprocal of cosine, which is going to be, oops, I can't spell, inverse secant. Okay. The other three have answers between negative pi over 2 and pi over 2. So that's inverse tangent, inverse sine, and inverse cosecant. All right, so then what we're going to do is we're going to get started trying some of the homework problems to make sure you actually understand what we're doing here. On the homework, I want you to notice that the notation might be different. Instead of saying inverse sine, it might say arc sine, okay?